Hello student, welcome to our 6th lesson, and our subtopic today is balanced chemical equation. Balancing chemical equations. The chemical equation is correct if it is balanced. An equation is balanced when the number of atoms of each type of a reactant is equal to that on the product side. So the reactants are usually on the left hand side when the product are usually on the right hand side. So the atoms should be equal for each type of element. This is because atoms are neither created nor destroyed during chemical reaction. Following the following guidelines should be observed when balancing a chemical equation. First, write the chemical reaction in words. For example, copper metal reacting with oxygen gas to get copper 2 oxide. Then 2, write the correct chemical formulae for both the reactants and the product. And to make it easier, first of all deal with the product to understand how the formula will be using the valency. So copper 2 has a valency of 2 and oxygen has a valency of 2. So in simplest form, you cancel by 2 to get 1. So they interchange the 1 to get copper 2 oxide. That is the formula of the product. Now you combine this one with the reactant, which is copper plus oxygen, and it is good to note here that this oxygen is in molecule form. Gases do not exist as atom. That is why oxygen carries these two, because this is a molecule, and then to form copper 2 oxide. This is unbalanced. And it is good to note that we use arrows, we don't use equal sign. So after you have done that, you'll note that the number of oxygen atom this side is more than the number of oxygen on the product side. So here it's 1 and these are 2. So you need to check on that. When you check the number of atom of either element equal, is not equal or equal, then you now balance using the multiplication of the number. If the number is not equal, multiply chemical formulas containing the unbalanced atom with the lowest common multiple. That is, in this case we noted that oxygen were not equal to oxygen on the product side, so you multiply 2 here, but now this one changes now the number of copper atoms. Therefore, you need to balance by putting a 2 here, a multiple, the lowest common multiple. So in this case, this one is balanced, but it will not be correct if the state symbol is not indicated. The chemical formula of the reactant and product should never change during balancing of the equation. A chemical equation is correct and complete if physical state now of the reactant and product are indicated as shown below. In this case, we have copper, which is a metal and is a solid, as a solid state. Gas, oxygen gas, G, and this one we have copper 2 oxide as a solid. So that is now a balanced chemical equation between the action of copper and oxygen gas. Example 2, zinc granules reacted with dilute hydrochloric acid, liberating hydrogen gas, and a solution of zinc chloride is formed. So the word equation is zinc plus hydrochloric acid. Put an arrow there to get zinc chloride plus hydrogen gas. So remember hydrogen gas, it is H2. The chemical is correct in correct symbols. We have Zn plus HCl plus give you zinc chloride. So the 2 here is coming from the zinc, this one. So the valency of zinc is here 2, therefore the interchange with 1 with chlorine is 1, then the gas is H2. There are 2 atoms of chlorine, where there are 2 chlorine atoms and 2 atoms of hydrogen on the product side, while there is 1 atom of chlorine and 1 atom of hydrogen on the reactant side of the equation. Therefore, the number of each of the atom on both sides of the equation should be equal. To balance the equation, 2 molecules of hydrochloric acid are used. The number 2 is written before the formula of hydrochloric acid. The balance equation is zinc. You put a 2 here to make the 2 chloride atoms here, so you put a 2 there so that there will be 2 chloride atoms and 2 for the hydrogen to balance. But this one is not complete if the state symbol is not indicated. Thus, to complete the equation, the state symbol have to be placed. So we have solid standing for S, then we have liquid L, we have gas G, and we have aqueous. Then balanced chemical equation for this will be zinc, which is a metal, solid metal. We have hydrochloric acid dilute, it has some water, so that is why AQ. And then zinc chloride is soluble in water, so it is aqueous form. And then we have hydrogen gas G. Balanced chemical equation, we continue. When metal burns in air in presence of excess oxygen, it produces metal oxide. For example, we have metal plus oxygen gas, you'll form metal oxide. For example, magnesium reacting with oxygen gas. Remember, you can see 2 here. This is oxygen gas, or a molecule of oxygen, does not exist as an atom. This one will form magnesium oxide. But when you look at the number of atoms, here we have 1 atom of oxygen and here we have 2. So we need to balance this by placing a 2 here and also placing a 2 here, because when you place 2 here to balance oxygen, magnesium changes to 2 and then we need to balance here. So we place 2 there and there. So, and then for calcium oxide, you'll find that calcium will react to form calcium oxide, valency 2, the valency 1, valence 2, 2, so you cancel out to get 1, 1 calcium oxide. But calcium here, or the oxygen here, is 1 and this one are 2. So what do? You place a 2 here and then you place a 2 here to balance the atoms. Move to the other one, sodium and oxygen gas. In this case, it is not balanced because we have oxygen here, which is 1, and these are 2. So you place a 2 here to make 2, and then 4 to make balanced. So the other one, metal reacts with water to produce metal hydroxide and hydrogen gas. So when metal reacts with water, it produces metal hydroxide and hydrogen gas. Example, we have magnesium plus water, you get magnesium hydroxide, and since magnesium has a valency of 2, then the 2 will go to the radical hydroxide 2 there, and hydrogen we have 2. So in this case, the number of hydrogen atom on the product side are 1, 2, then 3, 4. So to make this one balance, you have to place a 2 there to get 4. When you place 2 there to get 4, then magnesium is okay, oxygen will be balanced. Then we move to another one, calcium plus water, you get calcium hydroxide. When you look at calcium hydroxide, calcium has a valency of 2 because it is in group 2. So hydroxide will take the valency, and hydrogen here are 2 and this one are 2 again, so this one makes 4. But the other side we have only 2, so you place a 2 here to balance the number of hydrogen atom on either side, and this one also balances the number of oxygen. Lithium plus water, you get lithium hydroxide and water. In this case, we have hydrogen, which are 2, and this one is 1, so these are 3, and the other side we have 2. So in this case, you place a 2 here to make them 4, 4, so that this one you place a 2 here, then to get 4. Oxygen will be okay, and then you place 2 here because we have lithium, and so we have to balance all the atoms. Potassium plus water, you get potassium hydroxide, and here we have oxygen, hydrogen, 2, 3 that side, and then we have 2 here. So we place 2 here to get 4 hydrogen, so it is 2 times this one, you get 2 plus this one 4. Then you place 2 here to get 4. Oxygen will be balanced, but potassium we need to place another 2 there to get it balanced. So metal react with acid to produce salt and hydrogen gas. For example, we have metal plus dilute acid, we have magnesium plus hydrochloric acid, you form magnesium chloride plus water. Here you're going to find that chloride are 2 and hydrogen are 2. In this case we have chlorine, which are 1 and 1 hydrogen atom, so you place a 2 here to get the equation balanced. Then calcium plus sulfuric 6 acid, you form calcium sulfate and hydrogen gas. In this case, calcium has a valency of 2, sulfate a radical 2, so they cancel out, so they interchange 1 1, and the formula of the salt is calcium sulfate that way. Now let us check the number of atoms. Hydrogen 2, hydrogen 2, calcium 1, calcium 1, sulfur 1, sulfur 1, and oxygen we have 4, and these are 4, so the equation is balanced. We continue. Magnesium plus sulfuric 6 acid, we have magnesium sulfate 2 2, so you cancel, you get magnesium sulfate plus hydrogen gas. Then let us look at the balancing. We have hydrogen 2, hydrogen 2, sulfur 1, sulfur 1, oxygen 4, 4, magnesium 1 1, so it is balanced. Calcium plus hydrochloric acid, we have calcium chloride, so calcium has a valency of 2 in group 2, while chlorine, which is in group 7, a halogen, is in group 7, so it requires 1 electron to be stable. So 1 valency, 2, so they interchange to form this salt. So calcium chloride, we have 2 here, and we have 1. Hydrogen are 2 on this side, and this one there are 2, so you place a 2 there to get it balanced. Metal oxide, we react with acid to produce salt and water. It is good to note metal plus dilute acid produce salt and water, hydrogen, and in metal oxide with acid produce salt and water. So the metal oxide, you get metal oxide plus dilute acid, you get salt and water. Example, magnesium oxide plus sulfuric 6 acid, you get magnesium sulfate. So magnesium has a valency of 2 because it loses 2 electrons to be stable. It is in group 2. Sulfate is a radical, has a valency of 2, so you cancel by 2 1 by 2 1 to get this formula of this salt. Then we have water. Now let us go to balancing. For magnesium, we have 2 and 2 this side. For hydrogen, when you look at the number of oxygen atom, we have 5. These are 1 plus 4, you get 5, and the other side they are 5. When you look at the magnesium, they are okay. So calcium hydroxide plus HCl, you get calcium chloride. And so in this case, you need to balance by placing a 2 here, and then you balance. You place a 2 here. Then lead oxide plus nitric acid, you get lead nitrate plus water. Metal hydroxide react with acid to produce salt and water, and it is the same reaction. So metal oxide plus acid and metal hydroxide produce the same salt and water, and this one produces salt and water. So sodium hydroxide, you get sodium sulfate plus water. Then sodium hydroxide plus hydrochloric acid, you get sodium chloride plus water. And we have metal carbonate react with hydrochloric acid to produce three products. We have salt, water, and carbon dioxide. Example, we have sodium carbonate and hydrochloric acid. They produce sodium chloride, then they produce water and carbon dioxide. Here we have sodium carbonate plus HCl, you get sodium chloride and water plus carbon dioxide or carbon dioxide. So you balance by placing the tooth here. Then calcium carbonate plus nitric 5 acid to form calcium nitrate plus water and carbon dioxide. So you place 2 here to get it balanced. It is good to note here that calcium has a valency of 2 and nitrate has a valency of 1. Since this one is a radical, it will be in bracket, and then you place the 2 here, which is a valency of calcium. So they interchange. The same case that happened here, sodium and carbonate. So they interchange to have the 2 here because carbonates carry a valency of 2, while sodium, which is in group 1, carries a valency of 1. So we interchange with the carbonate. Copper 2 carbonate plus sulfuric acid 6 acid will form copper 2 sulfate plus water and plus carbon dioxide. Then we have sodium hydrogen carbonate and hydrochloric acid. You get sodium chloride, water, and carbon dioxide. This is a balanced equation. So sodium hydrogen carbonate, HCl, and you get that. So it is good to note, even in other levels, that metal carbonates or hydrogen carbonates react with hydrochloric acid to produce 3 things or 3 products: salt, water, and carbon dioxide. Finally, there is the exam for you. Work them out. Remember not to confuse the symbols. Don't forget to write the symbols, the state symbols, and also write the correct formula of the salt or maybe the product. Thank you and wish you the best.